like it stores all the keys in a sorted order, it stores all the keys in a sorted order, and it supports multi-columns, wide column database. So we use HBase, RabbitMQ, and Zookeeper as our building blocks for Clockwork. Let's look into the architecture from a very high-level perspective. In the left, you will see all the services trying to interact with Clockwork. We have HBase as our durable store, RabbitMQ for our messaging for doing any kind of asynchronous operations, publisher-subscriber operation, and Zookeeper as the brain or the coordination layer. I will cover each and every aspect of the architecture, but this is how the high-level picture looks like. Let's look into the first module, job acceptor module. So this is a lightweight module. It's responsible for accepting incoming job request and storing that job in HBase, which is our durable store, and provides an acknowledgement to the client. This is a very fast operation, generally covered in a single-digit millisecond, because all we need is to store the job details in HBase and give an acknowledgement. So this gets covered in around single-digit millisecond latency. Second is our leader elector. This is where things get tricky, because once you write a job to HBase, we will need somebody to figure out who or which instance is responsible for this job. So assuming there are multiple instances of Clockwork running, we want one instance to pick that job, not all. Why? Because if multiple instances try to pick up that job, then they can try to do same job can lead to multiple callbacks to the downstream, which is not the requirement. We want to do effective ones. So what we do is we follow a shared nothing architecture. By shared nothing, I mean we logically divide the job range into subsets. Like we partition the job range by just assigning partitions to a client. Since Clockwork is multi-tenanted, what we do is we assign now partitions to a client. So let's say a merchant client comes up. During onboarding, we say, hey, merchant, you will be getting 16 partitions. So each job will be mapped to one partition by simply doing a hash modulo by the partition count. Now, these are just logical, nothing to do with any database partitioning or something. This is just a column in the HBase saying that which partition this job is getting mapped to. Now, for each partition, we choose an instance as a leader using Zookeeper. So Zookeeper, as I mentioned earlier, is our coordination layer. It brings coordination or consensus to our distributed system saying that which instance is responsible for which partition. So in this case, let's say we have 3 instances running. So Zookeeper, every instance will try to write a Z node, write a path in Zookeeper saying that I want to be the leader for, let's say, partition 1. But only one of them can succeed. So the remaining one, which has failed, will try to set up a watch. Like they will get notified. If, let's say, instance 1 dies, they will get a notification or a watch saying that, hey, something has changed. Do you want to reacquire a leadership? So that's how we ensure only one instance becomes a leader for a partition. So once a leader is chosen for an instance, once a leader is chosen for a partition, that leader is responsible for assigning the partitions, remaining partitions, to other instances. So for example, here, let's say payments has 3 partitions. Once a leader has been chosen, it checks how many instances are available. Based on those, it tries to assign all the partitions to various instances in a round robin manner. So in this example, we have 3 instances, 3 partition. So leader A, instance A is the leader. So it chose one A as the leader for the partition 1, B for 2, and C for 3. So each partition gets mapped to one instance. Here you can see the leader itself is a worker. Like basically, leader responsibility is not just assignment, but also it gets mapped to one partition. So that's that. Now, once this data is being written to the Zookeeper, each instance checks whether I am responsible for any partition or not. If yes, then they start like they activate their scans. I will cover what is scan, but then they get notified basically saying that I am responsible for partition 1. So they will be the sole responsible for scanning partition 1. In this case, A will scan partition 1, B will scan partition 2, and C for partition 3. It's a shared nothing architecture. They won't interfere in each other's scan. That's how we scale. Now, when I talk about scanning, how does scanning works? Since HBase stores the keys in an ordered manner, and that's a very key benefit that we get out of the box, because Clockwork, as you know, is a scheduler. So we want to schedule a job that is happening at, let's say, 5 p.m. first before a job that is to be scheduled at 6 p.m. So naturally, we get an ordering, and HBase helps for that. So here you can see the schema on the right side that I have mentioned. The schema is client ID, partition ID, and timestamp. So each instance is responsible for a partition for a client. So they make an scan saying that, hey, give me all the jobs whose row key is less than or equal to client ID, partition ID, and current time. So this way, we will get multiple jobs that are supposed to be eligible for execution. So in this way, since each instance is responsible for only a subset of a range, they won't interfere with others, and they will only scan the job that they are responsible for. Since these are all independent scans, this allows us to scale and keep the design scalable. If, let's say, the traffic increases, what we just need to do is increase the partition count and let more workers scan. Now, once a scan is completed, what happens next? We push that job to RabbitMQ, get an acknowledgement, and once an acknowledgement is received, we delete that job details from HBase. Why do we do delete? Because if we don't do delete, this scan keeps on happening, right? So same job will be scanned again. So in order to avoid that, we do delete the job once we get an acknowledgement from RabbitMQ. Why do we push to RabbitMQ? Because this is a classical pub/sub problem. We want to do our scans as fast as possible and let the actual callbacks happen in a different thread. We don't want the scanner thread to block, because callbacks are asynchronous and they require a HTTP call to the downstream, which can be down where we have to perform retries, sidelines, and all those retry policy. We don't want the scans to block on that. So we let one thread scan quickly and then push to RabbitMQ. Once an acknowledgement is received, we delete the job details from HBase. Then move on. This loop keeps on happening every 5 seconds. Everything is customizable. We keep on repeating this scan to find an eligible job without much delay. Then now the last piece of the puzzle is RabbitMQ consumer. RabbitMQ is based on a push model. So when a job is pushed to the RabbitMQ queue, it pushes that detail to the consumer. We have Clockwork instances running, which acts as a consumer of RabbitMQ. They get those details, and then based on the job details, they make a callback to the downstream, get an acknowledgement, and once an acknowledgement is received, they act the message. So RabbitMQ has a property of act and neck, where if you act, then the message is deleted. If you neck, then based on the policy of retry, like it can requeue the message again. So this helps in case when let's say the Clockwork instance gets down after making a callback, but before acting. So this gets the ability that the RabbitMQ will requeue that message if in case an ACK is not received. So that's how we get or ensure at least once guarantee that so we receive an ACK from the client, and let's say if the client is down, then based on the retry policy, if let's say they have set up retry or they have set up drop policy, they want to discard the message, based on that we either sideline the message or push to a sideline queue or drop the message based on the retry policy. So that covers the entire flow. Just doing a recap, payments, all our clients call to make a schedule request to Clockwork. What we do is make a simple entry in HBase, give them an acknowledgement. That covers the write flow. Asynchronously, we use Zookeeper to divide our entire range into subset and follow shared nothing architecture. Each job is mapped to a partition. Each partition has a leader. that leader is responsible for assigning all the partitions to various instances so that each partition can be picked up by exactly one consumer or one instance. Once an instance scans that job, it pushes to RabbitMQ, gets an acknowledgement, and deletes the job. Then there are asynchronous consumers that get notified by RabbitMQ in case an eligible job is pushed to their queue. They make the callback, and once a callback is received, they give an act which deletes the message from RabbitMQ. Since we don't need any kind of replayability, we don't use Kafka, RabbitMQ works just fine out of the box for us. So that covers the entire flow. Let's look into the challenges. First of all, our traffic, because it's heavily bursty, like many of the clients, what happens is they try to schedule a job at midnight. Like for example, let's say there are million of merchant. The client, like the upstream client, they just say, hey, give me all the callbacks for, let's say, million merchant at the same time, let's say at midnight. So what happens, HBase, because our scanners are very fast, they will just scan, push the eligible jobs into RabbitMQ, and just move on. They will keep on publishing. They don't need it's a decoupled publisher subscriber, right? So they don't need an acknowledgement from the consumer. But in case of RabbitMQ, a bursty, like a million of messages gets enqueued to the queue, which degrades the cluster. We have seen instances where our RabbitMQ cluster has gone out of memory at night because someone scheduled a burst, like scheduled millions of jobs to be scheduled at the same time. What did we do? We moved to quorum queues. So quorum queues are a separate or a different type of queue recently introduced in RabbitMQ. This is based on a Raft protocol, which actually enables high throughput without sacrificing on durability or availability guarantees. Just by moving to quorum queues, we received around 1.5x more throughput over the previous default lazy queue. We heavily benchmarked our RabbitMQ cluster based on our production scenarios and tried to find what is our breaking point. Based on our benchmarking, we set up a distributed rate limiter. I will cover how we did that to protect our database from going down. We enabled back pressure so that if in case because we can't control our client scenario, client traffic, we can't ask them to stop, hey, don't schedule at midnight or something. We have to make our system resilient enough so that in case, let's say, billion of jobs happen to be scheduled at the same time, we don't want our system to fail. That's where the resiliency in platform comes into place. So we benchmark our RabbitMQ cluster. We figured out our breaking point, and based on that, we set up a distributed rate limiter. Let's look into some real-world performance number. This is based on the benchmarking which I did. So on the top, you can see the lazy queue type, and on the bottom is the quorum queue type. So on the lazy queue, if you see the same cluster, nothing has changed, same 3-node cluster, but the publish rate was barely touching 40,000 RPS, and if the consumption rate was constant at around 20K. You notice that the publish and the consumption rate are quite flaky. This introduces lag, right? Publisher is producing at a faster rate, but the consumer is not able to catch up. So this is where the lag is coming. But in case of quorum queue, you can see the publish and the consumer act is at constant rate of 60K. So this clearly demonstrates that quorum queue is able to handle the scale much better without introducing lag, and nothing has changed. Same cluster, same durability guarantees, same availability guarantees. So yes, configuration do matter. Now let's look into the distributed rate limiter that we implemented to prevent our database cluster from going down. We, again, based on the same design principles of shared nothing state, we leverage that to create a very simple and effective rate limiter. Since we use Zookeeper, so we already know how many nodes are available, total number of Clockwork instances are available. So based on our benchmarking, we know the breaking point. So we can easily determine if, assuming there is a uniform distribution of ingestion per node, so we can keep in hard, we can just uniformly divide, let's say our ingestion is 45K, keeping a safe number, we divide it by number of n, and we get a safe limit per node. Then we can use a Guava in-memory rate limiter to basically rate limit basically not publish more than that rate. So Guava rate limiter has this property that if you are trying to publish, let's say, more than 10,000 messages, which is our rate limit, then it will automatically sleep. So this naturally creates a back pressure because the same thread that is trying to emit a message in the RabbitMQ, that will get blocked for that duration, and the scanner will block. Because on the same thread, if you notice, or go back to the previous slide, you will notice that in the same thread, in this thread itself, we are pushing to the RabbitMQ. So if the thread that is pushing to RabbitMQ gets blocked for a certain time because the rate limit has exceeded, then the scanner thread will also block because it's in the same thread. So this naturally introduces a very natural back pressure without us doing any complicated callbacks or something like that. So this gives us this back pressure propagation. So it's a very simple and effective strategy without having any single database, distributed database to keep a sort of rate limit. Second thing, how we scaled RMQ is we found that RabbitMQ queues are very CPU bound after certain after certain RPS. Each queue was getting mapped to a single core because RabbitMQ is based on Erlang, and the way it works is each queue is mapped as a process, and that process is pinned to a core. So we found that per queue, if each queue has a fundamental rate limit, or basically fundamental limit to which we can push. Per queue, we were seeing after 10K RPS, we were not able to get in much RPS because the queue saturate. If you look into the stop and figure out what is the CPU utilization, we were figuring only one core is getting 100%. Rest all cores were empty. Why? Because that core was pinned to a thread, pinned to a queue, and that queue core, since the core itself is saturated, even though the capacity is there, the RMQ is not able to scale. So we introduced or sharded our RMQ queue. This is not an layer which is provided out of the box by RabbitMQ. We did the sharding from the application layer. Sharding is nothing but we created multiple queues for the same client. Because we are a multi-tenant system, we create multiple queues per tenant. Let's say for merchant, we create one queue. For payment, we create one queue. And for each queue, we shard it, basically have 5 queues, let's say, or 10 queues. And the application will randomly choose one queue while pushing. So this is just an application level sharding. This ensured, or this provided us this ability to scale without saturating our CPU. Now, let's look into how did we scale HBase. HBase, just a quick, a 1 minute high-level overview of HBase. HBase stores the data in something known as region servers. So what happens is, if you create a table, HBase try to assign that table into a region server, and if that data is present in only one region server, that region server becomes the hotspot. So in order to avoid that, what we did is we pre-splitted tables at the creation time to avoid hotspots during scans. So in the left, you can see for client 1, when we created table 1, in case the table 1 was mapped to region server 1, that is a physical shard. But let's say, and in the case of client 2, which was mapped to table 2, the RPS is 100, and the same client 1 has 10K RPS. This is 100 times more RPS. Both are mapped to a same, different region server. So this is naturally not going to scale because the entire traffic will go to one region server, whereas the other region server will remain idle. So we pre-splitted the entire table into various independent range, similar to our partition policy in case of HBase that we talked about earlier. So this allowed us to distribute the data in various region server and get better IOPS without wasting the bandwidth. Let's look into some of the metrics. Here you can see our peak RPS has reached around 100K RPS, and it's a highly busty traffic. This is probably at midnight when the traffic reached around 100K. And the remaining average RPS is around between 20 to 50K RPS throughout the day. This is a metric lag for our top client payments. Here you can see our P99 lag is under 5 seconds. Like it is around hovering around between 2 to 3 seconds in this chart. This lag is there because every time the scanner happens, right, there was some delay. If you note, there was some delay in which the scan happens. So that's where the delay is. And naturally, we can't go less than a certain number. So our lag is currently, we are targeting lag of P99 under 5 seconds. We process around 3 billion callbacks daily. So this is a stacked graph. So back, like the original article says 2 billion. That was last year when I initially submitted this draft for the RootConf. But by then time, like within around 1 year, our traffic has increased by 50%. So from 2 billion, it's now 3 billion. So you can notice that only there are some clients which are heavily causing that traffic, and rest all, like it's a 80-20 rule. 80% of the traffic is done by 20% of the clients. So same thing here you can see. Top 3 clients contribute to around 2 billions of jobs, and remaining 100 clients contribute to remaining 20% of the jobs. So yeah. That's it for my side. Happy to answer any questions if you have. I have linked the tag blog in here. If you want, you can go to the tag blog. Yeah, that's all I had in mind. Yes. Yeah, definitely. So at that time, we started this project in 2017. Back at time, there was no such thing as temporal. So that is one thing. And based on our scale, because our temporal works when you have a multi-step workflow where you want to do something, let's say, orchestrate a various DAG. If you have a DAG, in our case, it's a very lightweight. We just make an HTTP callback. Our requirement is it should be able to scale bursty traffic and just make an HTTP callback with durable guarantees. So based on our use case, like currently itself, temporal is not a right fit because we don't want workflows. We just want in HTTP callbacks. Temporal provides much more capabilities than what we need for. Yes. 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 Okay, so the question is that if you are asking the partition count has changed, right?
No partition count, or let's say one get removed, one get added. Let's say earlier instance ID 2 was mapped to partition.
Okay.
But let's say in future partition 2 got removed, its place was taken by a new partition, or partition 3
Okay.
got named as partition, something like that.
Oh, so okay. All
Like
right. Fair question. So the thing here is that partition count is tied to the instance, like to the table at the time of client creation. So that is fixed. So we don't change because we can't reduce the partition count. We can only increase the partition count. Now your question is, let's say if a partition is 10. Now if at the time one instance was mapped to one partition, and during rebalancing, let's say that node goes down, that instance, like some new instance becomes the leader for the other partition. So there can be a time when the same job could have been picked by 2 instances, because always there is lag. We can't introduce like say okay, the deactivation of partition from one instance versus activation of partition by another instance can be done in a consistent manner. So there can be a time when the same job can be picked by 2 instances. So that is why we need support from the client also to do effective ones. Like basically each job, they can have some sort of an identifier, idempotency key, so that when a callback, multiple callbacks they receive for the same job, they can dedupe from their side. Because doing exactly once at distributed systems with 100K RPS is not easy. So that is why we do or guarantee at least once. And if the downstream client provides idempotency key, then it will be effective once. So I hope that answers the question.
Yeah, and another question I have.
Okay.
So currently RabbitMQ would be having consumers that would
Yes.
be consuming messages, and the load you said is variable,
Absolutely.
How do you like scale up the consumers, or you keep a similar count?
So we keep a static count of consumers. We do have auto scaler service that is a best practice that we follow. That if our CPU utilization goes below, then we scale down our consumers, and if it increases, but auto scaler has a as you know, auto scaler does not kick in immediately, right? So we tend to slightly over provision by 20-30% so that we remain warm. And in case there are peaks, because we don't know, we can't anticipate the future, right? So we keep it slightly over provision to handle spikes. But our currently 30, not more than 20-30 consumers are running. So it's a very minimal stack that you can expect. 20 consumers or 20 instances that are responsible for scanning and pushing and consuming. So everything is done by a same instance. Like all the responsibilities are handled by the same instance. So we don't, because it's just 20 boxes, 20 virtual machines, 20 app instances basically. So it's, since the infra footprint is so low, we have not decoupled the architecture led by creating a dedicated publisher, dedicated subscriber, something like that. Thanks. Yes.
I have a question around your RabbitMQ.
Okay.
I saw you showed that every time the scanner will pick the job,
Yes.
will put in the queue and delete the entry.
Yes.
So if your cluster that queues for RabbitMQ, if that goes down,
Yes.
do you have a durability already since you're managing the whole cluster, right? You're not using any managed.
Yes, absolutely. Yes.
So just wanted to check how you adding the durability and fault tolerance.
So first of all, yeah, so the question is how do we add durability in case RabbitMQ goes down, right? Okay. So the answer is ki HBase is our source of truth. RabbitMQ is just a messaging broker that coordinates for publisher, like basically links or couples the publisher and subscriber. So if let's say RabbitMQ is down, then the publish will fail. Since the publish has failed, we won't be able to delete the message from HBase. So the data is still present in HBase. It will keep on scanning. Like the same row will keep on scanning in the same loop. So the new job will not be scanned. So there will be a head of line blocking because we won't scan the new jobs. We have to scan the current block. And if RabbitMQ is down, then yes, it's a basically all hands on deck. So we,
My question was when you have like your RabbitMQ
Okay.
has acknowledged that okay, I have received.
Oh, okay. And the consumer part you meant.
Yeah. After that, in between there will be a time limit, right?
Yes, definitely. So, so I understood. So basically, you're saying that publisher has got an acknowledgement, and then after deletion, so you're saying the consumer has not received an acknowledgement. Okay, so that has happened. So that is where I mentioned our scenario in which our out of memory, the cluster has become out of memory because our ingestion rate to RabbitMQ was so high that the cluster went out of memory. So in that case, since we use quorum queues and by default it provides durability guarantees. So once an acknowledgement is received by the RabbitMQ, we use a 3-node replicated cluster. So in each node, like each message is replicated thrice. It's not that on just one node. So we can handle 2-node failures. That is first thing. And second thing is if, let's say that node is restarted or something, RabbitMQ ensures the durability. So only thing is we have to ensure is that we need to get an acknowledgement back from the RabbitMQ. Once we got an ACK, this means that it has replicated to 3 nodes by reft. Like basically RabbitMQ uses reft, quorum queues for replication, and that handles the consensus for us.
That I missed that.
Okay.
You're managing this whole thing.
Okay. Sure. Thanks.
I just have one question. Just want to understand, like, what's the use case for Clockwork?
Okay.
You know, like when we use PhonePe, like usually we are scanning, and then entire payment is happening, and we are finally as a customer handling the acknowledgement. Is Clockwork used as a job scheduler there? Or I think you mentioned that it's being used, you know, during the night time for scheduling.
Yes.
Yeah,
definitely. So the use case that are mentioned here is mostly kind of asynchronous, but on the payment side also Clockwork is heavily used for reconciliation because see 90% of the time payment succeeds, no issues. But when those 1% cases when the payment has failed, right, is stuck, you might have been seeing the loop going on in the app. So this is where the Clockwork helps in reconciliation. So when you triggered a payment, at the same time payment service triggers a callback in Clockwork for this transaction after 1 minute. So then after 1 minute, Clockwork will give them a callback for reconciliation so that they can check the status, whether what's the status of this payment. Is this completed? Is this failed? Is it stuck? And then they can trigger the reconciliation process. Because if there was no Clockwork in the payment reconciliation flow, then what would happen is payment would have to do something manually on their side or kind of in a batch. Like they would have to scan the entire database, figure out, hey, what is the timeout for this transaction, which is expensive and which will not work at scale. So to do that, to handle reconciliation, real-time reconciliation, payment uses Clockwork in that path.
Why don't you use some kind of status and just not trigger the Clockwork if you already know that the payment is already?
We don't know. That is what. We don't know payment, because payment, when you make a payment, it goes through a multi-hop process, multiple banks, multiple intermediaries. We don't know at which point the payment can get stuck. And we want to ensure reconciliation as fast as possible. So that is what, it's an optimistic process. 90% of our payments go through, but only those cases where it's stuck matters. Like at those places, we want to ensure the reconciliation happens fast because we don't want the customers to get stuck. So that is the case. Yes. Yes, because there are multiple, it's not a sync. Payment does not happen in sync. It is asynchronous, multi-hop process, multi-state. So we don't know.
I was asking this question majorly because I was thinking that instead of having a system, in case it is mostly a batch project where you are batch process, you may basically use an existing architecture like you have Spark based.
Yes. No.
Right, which has everything already available. You have Jupyter.
Hmm.
The entire ecosystem itself is there and it's super fast as well with the new systems. That's why I was asking. But I think that answers the question.
Yes.
Because you have to do that everyone has to ensure that the payment has.
Yes, so if you see the lag, which I mentioned earlier, our P99 lag is under 3 seconds. So yeah, callback frequent, and we have received, like it's a production issue. We have seen when the callbacks to payment has been delayed, and we have seen production issues happening. But yeah, because if the reconciliation is late, if they receive late callbacks, then payment, like the actual clients will suffer because they will keep on seeing the payment is stuck. So we want to avoid that. We want the status to get reflected as soon as possible. That is what. Yes. Yes.
First is the previous question with
Okay. Okay.
you said 90% of the jobs or the transactions goes through, 10% fail.
Yes.
Those 10% of the 3 billion transactions that you are targeting?
No, these are all the transactions, because Clockwork does not know whether a transaction has failed. At the time of schedule, payment has scheduled a, let's say, callback, saying that give me callback after 1 minute. So these are all the payment processes that has happened. Let's say over the day, 1 billion jobs, 1 billion transactions have happened. So each billion is attributed to one job here.
Second part of the question is, since it's a payment system, right, you might be doing end of the day job processing.
Absolutely, yes.
Part of this is
Yes, yes. So end of the day is like this daily merchant settlement, coupon invalidation, and all those things.
end of the day.
Yes.
Saying that, since you know that you will be doing end of the day, it's like that is a banking hours, right? Midnight. Midnight is not our midnight, it's banking midnight.
Yes.
So you will be having slots available, right? In terms of
Okay.
have the slots kind of stuff where you know you want to do end of the day.
So each of these systems, like we are a platform, right? So our upstreams are various applications or various internal teams. Each would have their own SLA to maintain or do some kind of an offline. Like they have their own SLA. Yes.
So my question is like, do you provide visibility in terms of the cluster is occupied this much, this is the time slot available, you can check.
Oh, okay. No. So our job is to make, like, I understand your point. Like, do you have some analytics or something like that to have a job basically so that cluster utilizes something like that, right? So people can try to do, but yeah, we are not at that state yet. Our requirement is to schedule that job as soon as possible. Like basically, if someone says ki they want to schedule this transaction or this settlement at 3 p.m. anytime, like we want to schedule it as fast as possible.
You don't have a categorization of workload time.
Yes, it's an HTTP callback. We don't do any kind of long-running jobs like execution of jar or Docker file or something. It's an HTTP callback, so it's a short-running job.
You mentioned it's a reconciliation job, but do not have exactly what you cannot. Are the idempotent
Yeah, so so the question is whether like do we have any kind of idempotency support out of like from the platform itself. So the answer is, as a platform we can't provide idempotency because we are there to make an HTTP callback. So while doing a HTTP callback, the client can provide certain parameters like post params or some. Absolutely. They can, while scheduling a job, they can provide, hey, you can use this key or this ID while making a callback. So that's how they can give. We will pass the same thing to them during the callback, and then they can maintain their own state.
Oh, I hear, sorry.
Yeah.
My name is Sarfaraz.
Okay.
So, how does the backend system look like? I mean, the front end I understand like a lot of tools like you mentioned Super and you mentioned HBase, right? RabbitMQ. But how does the backend look? Where exactly is it deployed? Are they deployed directly on the virtual machines or you are using Kubernetes kind of solutions?
Yes, so there is like we use in PhonePe we use a common stack. We deploy everything on Docker and deploy it on like we ship it as Docker, deploy it on virtual machines. The data the machines and everything are self-managed. We have our own data centers, and for the entire orchestration we don't use Kubernetes. Actually, there is a talk happening by our chief architect. We have our own in-house Drove, which is our container orchestration platform for shipping or basically deploying Docker containers at scale. It is very similar to Kubernetes, but it's again an in-house platform that we developed for deploying Docker images across our data centers.
So I wanted to discuss it majorly because I've seen, the cost impact on
Yes.
using Kubernetes kind of solution is huge, right? Because you do not have to, bring upfront virtual machines, right?
Yes.
It could be very costly in long run. But since you have your own data centers, that could be, slightly cheaper if we offset the maintenance cost, right?
Yes.
Management cost. But usually I have seen, the benefit, it actually gives at least 80 to 90% cost savings the moment you start basically using Kubernetes kind of solutions. Like, is there any plan to start using such?
Kubernetes. No. Currently, since we have our own in-house Docker container orchestration platform, so currently there is no such plans for it. Yes. Okay. Yes. Okay. Yes. Okay, sure. So yeah, like when I mentioned CPU, that is just one of the metrics. So we do have a lot of metrics because observability for a platform is it's just not a single metric. We do have, like as I mentioned here, we have this one also. Like we do keep track of callback delays, right? We do keep track of number of callbacks that has processed. So every time, if there is some kind of, we maintain the historical analytics as well. Let's say, like basically we have an in-house anomaly detection platform. Anytime the metrics or has not, like if there is any kind of deviation from the expected metrics, we do get alerts. But auto scaler is also triggered on, because this is a metric, right? Sorry. Yes, so auto scaler can be triggered on lag also. So it's not any limitation by the platform that it's not, enabled on what you call CPU just. But CPU is a very good metric for us. In case of, one thing is, if we enable auto scaling on various metrics, what can happen is noise. Let's say because of certain metric, there is a noise, and then let's say instances scale up. Then rebalancing can trigger, and rebalancing is an expensive operation because it creates lag. Because there are moments when the leader instance goes down, like because it will be deactivated, a new instance will be chosen as leader. So we don't want auto scaling to happen as much as frequently. It should be a kind of an exceptional event when a auto scaling happens, unless it's a rolling upgrade or kind of restart process that we are trying to trigger. Yes, it is. That is where we have alerts, like anomaly detection alerts, that the on-call gets paged to see whether consumer lag is is a real issue or not. Because sometimes, let's say consumer is down. If let's say payment is down due to some issues, merchant is down, the lag will be there. In that case, unnecessary, we will scale our instances. So that is why it's not always, one metric does not just make sense to scale.
One more question on
Okay.
that part is that the consumers, I'm assuming, is not the platform, or the platform is also controlling the consumers?
No, no. Consumer, the question is, are the consumers also related to platform? So the answer is no. Consumers is a separate, like these are separate applications, merchant, payment, which is like a separate ecosystem.
And how will, so is there any metric that you're exposing to scale of the consumers also if there aren't two, let's say, consumer licenses?
Oh, oh, okay, okay. So sorry, I misinterpreted the question. So when you say consumer, this is the basically this one. Yeah, so this one, right? So RabbitMQ, this is the part of the Clockwork itself. Do you mean this consumer, right? RabbitMQ consumer? Yeah, so this is the Clockwork itself. Like when a job is pushed to the RabbitMQ, so this RabbitMQ consumers are part of Clockwork itself, which actually get the job, and then they make a callback to the downstream. Yeah, so this is part of the application stack itself. Yeah, so it depends upon the client, right? So in the last line, you can see based on per tenant or per tenant, we have specified a retry policy. So if the client, let's say, specifies after 3 retries, you want the message to be dead letter, so we create a separate queue in RabbitMQ to create push that failed message in the dead letter queue.
And it's configurable.
Absolutely, it's configurable. So the client can specify drop as well.
Thank you.
Yes.
Thank you for the great presentation on insights on how we scale. Yeah, there's a lot of questions actually, so we'll move after the networking time starts. We can ask more questions. Now we have a second talk from Manas.
Yeah, that's it. You can
Manas is going to give a talk on agentic AI systems, the orchestration, the scalability, how they are handled. So it's going to use this. Yeah. This way. Yeah, thanks. The display. Built-in display. No? No?
Snehashish's laptop, or we have a spare laptop. You have a spare laptop?
Yeah, should I mail it to
We can move
him?
it to the spare laptop.
Okay.
Okay, folks, we just need 5 minutes to do a little bit of switching so that the stream audiences can also see the here, so you can ask him how you can also speak over here. We have the next meetup in Mumbai in June and then in Bangalore in July.
Should I remove this? For now.
Those who are interested, actually, they can submit via the website.
I see, Vala. Okay. Like, what do I do? The PPT is here. The file, I think, it should be there in downloads. 1 second. Uh, this one. It's a PDF. That works, right? But then I need. I think PDF should be fine, but I should be able to change the slides.
Databases also there is multiple teams are there. Based on your interest or your experience.
Right now, the microphone will be on. So right now it is on, right? Just turn it off. From?
switch on.
Okay, we can come back now so that Manas can finish and huge round of applause for Manas for flying all the way to Mumbai to talk in Bangalore.
Thank you. Then you will need the mic, right?
So now we have a next talk. I think there's a good tea and coffee here. Freshly prepared from the movie office, not from the machine. So yeah, thank you. So now we have a second talk from Manas. He is an architect in IDfy, and this is going to be on designing multi-agent systems, where he's going to cover on agentic systems, how the reliability, failure, and all the agentic new systems are being handled. He's going to do that orchestration also. Thank you.
Yeah, thank you. So hey everyone. So again, my name is Manas Chaturvedi. I'm an architect in IDfy. The title of my topic is Designing Multi-Agent Systems that Scale. Now, if you look at AI agents in general, right, individually in isolation, they tend to perform very well, right? So if you look at all the demos online, all the POCs, they perform very well because if you give an agent some set of instructions, some tasks, they work very well. The problem arises when you try to glue isolated, specialized agents together into a workflow. That is when things start getting messy. So what I want to basically talk about is some of my experiences while building this system, and some of the learnings. Before I start, by a quick show of hands, how many of you have actually built agentic workflows? I just want to understand from you guys, some of the challenges that you guys have faced. And especially on production, when you actually, deploy this on production for enterprise use cases, what are the challenges that you guys have faced? Hallucination, yeah, that's a big one. Anything else?
Not predictable, right?
Mm-hmm.
Works 90% of time and then 10% you get very unexpected results.
And the Murphy's law, when it fails, yeah.
Then even the systems are not very stable. The models which you are
Mm-hmm.
building pipelines, so you have to build your own layer of fault and tolerance and durability. So these are the few things which I
Got it. Anything else? Any other patterns?
The framework which we have used is going to absolute in next few months.
Sorry?
The framework which we are using, mostly the new framework.
Okay, it will be obsolete, let's say, in a few months or so. Okay. Yeah. I think you.
Always coming up with like deterministic result.
Mm. Understood. Anything else? Mm. Yeah. Mm. Yeah. Correct. Yeah, I can actually ask a programming question on the chatbot. Yeah. Right. Yeah. So I think I'm seeing a common pattern here. So hallucination, I think determinism of the output or the response. I think these are some of the challenges I think that we also faced. What we also did is, I think, so we had isolated AI agents in our workflows already. When we started building them together or gluing them together, we faced a few challenges. And then what we ended up doing eventually is we built our own framework around this. We abstracted a few layers, and I just want to talk about those aspects in this session. Before I proceed, I just want to quickly talk about what we do in IDfy. So IDfy is Asia's leading trust tech platform. And basically what we do is we help our clients ask or answer one fundamental question about their users, and that is, can we trust them, right? So for example, if I'm a bank, and if I want to sanction a loan, a personal loan to some of my users or a user, I would want to know, let's say, are there any court cases against that user or not? I would also want to perform some regulatory checks against that user, right? So we basically, IDfy provides all of those offerings, all of those product solutions to our clients so that they can completely trust their users for different use cases. We have 3 core platforms: the Onboard IQ platform, the Wondrous platform, and the Preview platform. And again, each of these platforms have different products and use cases that we have built underneath them. And all of them are basically powered by our API platform and various AI-powered systems. We operate across different industries. Our presence is in different geographical regions. So just wanted to quickly talk about, where we are coming from. I'll quickly talk about the problem statement. Now, most of the use cases or most of the products that we have in IDfy follow a similar, architecture or, have the similar use case. So any product that we see in IDfy has 4 different planes. The first plane is the data acquisition plane. Now, the data acquisition plane basically deals with fetching data from different data sources. Now, these data sources could either be, let's say, publicly available websites. It could be third-party vendors, data vendors that we have partnered with. It could also be, that data could also be derived data that we are, getting from our internal data that we have stored over the years, right? So the data acquisition plane in general deals with everything related to fetching the data and then, getting it from different sources, collating it. The second plane that we deal with is the data ingestion plane. Again, in data ingestion plane, depending on the use case and the data that we have collected and the type of data, we build, let's say, custom ETL pipelines, right? So what we do is, depending on the use case, for example, if search is my use case, I would maybe use Elasticsearch for storing my data. If, let's say, semantic queries are my use case, I would use a vector DB. If I want to, let's say, make sense of, let's say, different entities in my database or in my knowledge base and make sense of the relationship between those entities, I might use, let's say, a knowledge graph, right? So again, depending on the type of data, the use case, the product that I'm building, my mode of ingestion would differ, my ETL pipelines would differ. The last plane, so I'll skip. So the third plane is basically the orchestration and the intelligence plane. But again, this is not part of this scope. The fourth plane is the consumption plane, right? So this is how our users are able to, avail the offerings that we give to them. So there are 2 modes of consumptions usually. One of them could be our APIs that we have built. So we have about 170 odd APIs that we give to our clients. And we have the UI portals or the different UI UX products that we have built, right? And again, all of them are powered by our search layer that again sits on top of the data that we have stored in different data stores. Now, again, even though over the years we have built these workflows multiple times for different products, it is still, time consuming whenever we want to go live with a new product or a new use case, right? There are multiple data sources, different types of data. Data could be raw data. We would want to, let's say, write very complex extraction pipelines. A lot of engineering effort is spent in, building this entire thing together. So these are some of the challenges. and also not just tech bandwidth, right? I think in order for us to go live with a new use case or a new product, all the stakeholders across the company have to work for weeks or months just to get one product live. And this is again before we can even make money out of it, right? So product, tech, the designers, everyone is involved for months just to get one use case live. And we had built these kind of systems multiple times over the years to realize that, okay, there should be some other way, an alternate approach to build similar systems so that we can go live really quickly. And again, we would still have to do all of this, but then we wanted a way wherein we can, quickly go live with a new product, a new use case, get some market share, and then figure out, if it is worth spending a lot more time or not. And then, so the solution that we ended up building, and this is basically the crux of the topic that I'll be talking about, is that we ended up building an in-house multi-agentic framework from scratch, right? I'll talk about why we ended up building this from scratch and not use any of the existing frameworks in one of the later slides. But this is what we ended up building. Now, in the first point, especially in the bold ones, you will see a lot of technical jargons, right? So orchestrated, tool-augmented, multi-agentic, execution framework, so on and so forth. But then each of these jargons or each of these terms are actually very important when it comes from a design point of view, right? So when we were actually planning this framework or designing this framework, we consciously took some decisions which helped us to go live faster depending on our use case, right? The first one is orchestrated. I think a lot of you guys talked about, in agentic frameworks, the response or the output would not be either structured or deterministic, right? So for us, it was very important that, we control the entire execution of, how those agents are executed. So that is one. So we built an orchestrated engine or an orchestrated service that basically deals with, coordination of how agents talk together, and then how would they, execute in a given workflow. So that is one. We have a lot of tools that we have built, agent tools, which are agents leverage to, do their task. And I think what the second point is also very important. We never wanted a fully autonomous multi-agentic system, right? Again, for the same reasons that you guys talked about, I cannot, for my business use cases, I cannot rely on, let's say, an AI agent that can, take its call on its own, have free will, and then, generate some output for the users to see, right? I wanted full control over, how my workflow is being orchestrated. I wanted full control of how each agent in my system is actually, working, what are the guardrails that each agent would have. So we wanted control over all aspects of the workflow, which is why we basically built, a semi-autonomous agent, so to speak, right? And again, in production systems, obviously, predictability for me matters more than autonomy, right? So which is why we end up making the decisions that we took. I'll quickly touch upon the architecture of the system. And again, there are a lot of components here. I'll quickly talk about some of the important ones. The first one is the agent skills component, right? Now, agent skills is where, all the agent definitions reside. So basically, each of the AI agents that we have, we define the role of that agent. We define, the instructions that we want to give to that agent. We define the guardrails that agent should operate under or operate beneath. We also define things like, if let's say there are 10 different agents, right? We define rules like, okay, agent A can only talk to B and C, it cannot talk to anything else. We also define which tools the agent would have access to, right? So all of those guardrails, all of those custom instructions, the user roles, everything is defined under agent skills. And agent skills in our system are nothing but markdown files, right? So that is another aspect to it. Knowledge repository as a component is where we store all of our global context and global instructions, right? So any custom instructions related to a particular use case, for example, domain knowledge, any knowledge that can be shared across the different agents that we have are stored in the knowledge repository. Orchestrator is, again, a very important component in our case. The orchestrator basically decides how a particular multi-agent workflow is running or executed, right? Think of it this way. I think the analogy that I like to use is in terms of relating AI agents to humans. So let's say there is a CEO of a company, right? Now the CEO in this case is my orchestrator. The different employees of different verticals in a company are AI agents. Now each employee of each vertical, let's say each lead of each vertical is an expert in their own domain, right? They can do one task very well. And the job of the CEO or the orchestrator is to figure out when to delegate what to which agent, right? So what we have done is we have abstracted or we have basically decoupled the intelligence part of my system with the orchestration part. We don't allow agents to reason how to orchestrate within a workflow. We do it ourselves, and then each agent is responsible for reasoning within their own purview or within their own reasoning or within their own guardrails. And then the execution, so basically the way that memory is basically shared across the different agents in my workflow is through temporary artifacts that each agent creates. Right, so for example, if agent A wants to pass some information to agent B, what agent A would do is, at the end of its execution, it would create a temporary artifact file, let's say a JSON file or anything else. It will store it temporarily, let's say within the same container, and then orchestrator would then decide that, okay, fine, agent B should now be invoked, and agent B can take, let's say, the artifact that agent A had created. So that is how the memory is shared across the different agents. We store state in Redis. So that is another aspect. We use CLI command templates for executing our agents. So since our agent skills are nothing but markdown files, orchestrator decides when to call or when to invoke an agent by running these CLI commands. And again, we use either Claude or Gemini, it depends on the use case. Agent tools is again a very important component here. This is where we abstract the business logic, or anytime we want an agent to do some post-processing, or anytime we want an agent to interact with, let's say, internal systems or external systems, we basically abstract that entire logic inside callback functions, and we expose those functions as agent tools to our agents to use. And then obviously in agent skills, we also, as part of our guardrails, we basically specify which agents can use which tools. Any questions here? So I think I can answer the question at the end of it as well, but I just want you guys to go through this one more time. Any questions, I can answer it at this point.
What is the orchestrator?
So,
You have developed your own orchestrator.
R1. Yeah, it's a lightweight orchestration service, which basically each use case has a separate workflow, and each workflow has some orchestration rules that this service defines.
So why we have not used some common open source framework?
Yeah, I'll come to that, I think, in the third last slide.
Orchestrator is a deterministic service.
Correct.
Which just passes instructions on there.
Correct. So it's like if I'm a CEO, I know that, okay, the design lead would be handling this part of the project, the technical lead will do this, so on and so forth, and then those leads are, free to exercise their free will to do anything that they want within the guardrails that the CEO has set. Yeah. So this is the framework that we have built for all use cases. Yeah. No. So I'll talk about, I think, the rest of the slides will probably answer your questions, and then I can take but any questions related to this architecture at this point?
Just want to understand
Yeah.
the knowledge repository better. Is this the basically place where you ensure that your agents don't go
No. So there are two things here. So the guardrails controller that you see, which is part of agent skills, that is where we define the guardrails that each agent would have. The knowledge repository is where we have based on each use case, the custom instructions and some shared knowledge that each agent could use. So for example, in a given workflow, maybe report generation is something that we need to do. So the report template could maybe go under knowledge repository, for example. Yeah. It's still a boundary, but then it's a boundary that I've set for all agents and not particular to one agent. So it's still a guardrail, you can say, but then the agent-specific guardrails will still reside in agent skills.
And what exactly will be there in the agent-specific guardrails?
Things like, so for example, which tools that agent could use, number one, which other agents can, an agent could communicate with, what is the output structure of the response that each agent will generate. If the agent is, let's say, leveraging an external tool, an agent tool, for example, what is the retry mechanism, what is the execution timeout, so on and so forth. So we are not using any external framework, all of this is built in-house. And then obviously for our tech team, we have abstracted this out by building this framework. Mm-hmm. Okay. Yeah. Yeah, I think the slide where I talk about buy versus sell, or basically rather why we ended up building our own in-house framework, I think should answer that. We'll come to that, yeah. Yeah. These are basically third-party LLM providers that we are using. So that's it. So for example, if we are using Claude or Gemini, that is what it does. So so this is again a very lightweight service. It only interacts with, let's say your Claude SDKs or Gemini SDKs, so on and so forth, or CLS. No, right now, no. In some other systems, yes, but not in this framework. Mm-hmm. So all of that is taken care by the consumption plane that we have. So the APIs or basically the request validators, all of that is taken care by that. Yeah. By the orchestrator. So the orchestrator always decides if, the workflow at any given point in time is working as expected or not, or if the agents are producing the same or the expected responses or not. Yeah. So there are two aspects. So each agent skill would have the guardrail of, what it should have written as part of the response. And just to validate, the orchestrator will then, actually validate the response structure, if it contains, let's say, any PI information or not, so on and so forth. The response validator will basically, so what the orchestrator does is, it will deal with orchestrating between the different agents. It will collate the responses, and then the response validator will reassemble the final response once it has been validated and send it back to, let's say, the downstream service.
Maybe questions shall we take after
Yeah.
presentation?
Works.
Entire context we have.
Yeah. So I think some of the things that I think we had to handle as part of platform engineering. So one is all of these workflows, since there are multiple agents working together, are usually long running, right? Now in this case, what happens when, any touch point in my workflow fails? So what we do is at each touch point after the successful or failed execution of each agent, we store the state in Redis, right? And then that is how we know that, okay, fine, if, for example, in this example, if checkpoint 1 and checkpoint 2 was completed successfully, we store that state in Redis. And then if, checkpoint 3 fails, we know when we resume the workflow, where to start from. So the entire workflow won't be invoked from, let's say, checkpoint A, we'll resume from checkpoint 3 or C. Again, I think this was something that a lot of you guys were also talking about. How do we make sure that the workflow generates the same response given any same set of instructions or data, right? So a few things. So one is, I think the agent skills that we create, or basically the guardrails that we set for each agent, we define the output structure of each agent. That is one. So that makes the responses deterministic. Secondly, the orchestrator is responsible eventually to, decide whether to proceed with the execution in the workflow at each touch point, number one, and what to send the response to care by the guardrails controller that I spoke about. So each agent knows how many times it can retry, let's say, an agent tool call, what is the expected response, and then the orchestrator also decides for each agent what is the execution timeout, right? So we know, from this, we are able to ensure that, anytime an agent loops, the execution is timed out, and then we are able to handle that response gracefully. Similarly, with the API calls, I think for each tool call or for each API call, we have a retry mechanism depending on the use case, depending on the agent, and depending on the tools that we are using. For cost, what we have done is, again, we have set all the guardrails, everything. At the same time, we also instrument everything. So I think in IDfy, each product, is instrumentation first. By this, what I mean is, we log everything. Each touch point is logged. It is instrumented. We have alerts, in place. So depending on, the alert type and the threshold, alerts are always, triggered. So for example, if we know that for a given workflow, this should be the output token size, or this should be, let's say, the number of failure scenarios. If, that threshold is breached, alerts are triggered automatically so that we know when to, intervene, from a developer's perspective. And I think the guardrails that we have set will also ensure that, our costs never balloon up. So all of that is also under control. And eventually, anytime, anything fails in the workflow, the failure scenario is again handled by the orchestrator so that, the consumption plane, or basically the interface that, our users see, they are always able to get, determined outputs. It could either be a failure response or a success response. There are two main execution models. So I think from a scaling perspective, it's, again, a very simple architecture. Each workflow in our system has a dedicated queue, number one. And we use SCADA for, auto scaling based on queue depth. So that is one aspect to it. And since these are long-running tasks, we use queues so that, the other systems that we have in place, they are not affected by it. And then we have DAG-based execution. Again, there are two aspects to it. In some cases, we have certain workflows that need to be triggered periodically, right? For example, report generation for a few use cases need to be generated, let's say, every 12 hours or 24 hours. So in such cases, we use periodic crons. That is one. The second part is, and something that, which is very interesting that we have built, is self-healing agents. Right, so what we have identified is, in our workflows, in some of our workflows rather, there are certain patterns because of which our workflows fail. Right, so in such cases, what we have done is, we have created self-healing agents, what they will do is, they look at, the failed jobs or failed workflows, let's say in the last 1 hour or so, the self-healing agent will get triggered. It will autonomously figure out, depending on the code base and the use case and the failure logs, what the issue is. It will create an RCA. It will then also create a fix for that, bug. Then it will also use GitLab for, creating a master PR, or let's say merge request, share the link along with the RCA via notifications to developers. So all of that is done autonomously. And again, this is not implemented across all workflows, but for certain workflows where we know there are, common scenarios of failures, this works very well. Yeah. So I think this is a question that, we get asked a lot. Why did we not use, let's say, something like Crew AI, LangGraph, and other, multi-agentic frameworks in order to build this? Why did we build this in-house? The simple answer to that is, we never intended to build this in-house. I think what we did is, we had these long-running workflows already in place. Then we started figuring out that, okay, fine, some of these touch points or some of these aspects of this workflow can be automated by isolated AI agents. We started building those AI agents. Those AI agents in isolations performed very well because they were deterministic and we were only dealing with single agents. Then we realized that, okay, fine, why don't we just glue them all together, create a multi-agent framework, and then, also use it for other new use cases. And that is how, iteratively, the single agentic paradigm, got converted into this multi-agentic framework, right? So, and then, once we started seeing, or rather, once we started adding more and more layers of abstraction, we never felt the need to use or migrate the entire logic to an existing framework. Right? So that is one aspect. The second aspect to that is, I think all of the agent definitions that we have are currently defined by markdown files. And then usually what happens is, for a new use case, we don't need any tech dependency for an agent to work. So usually what happens is, someone from a product team, let's say a product manager who has a domain knowledge and they want to create a new use case, they'll simply create a markdown file in the template that we have defined. In some cases, they could simply leverage the existing tools that we have, or we can create custom ones, and then they just have to plug those markdown files into our framework, and everything else, works seamlessly. So I think by building this in-house, that has reduced tech dependency, and we are able to, play around with new use cases very quickly. That also allows us full control over execution semantics. So basically, by this what I mean is, I have full control over how a how a workflow needs to be run, needs to be executed, what should be the output at each stage, what should be the SLA for a workflow, so on and so forth, right? So I have full control over it. Domain optimized performance, and then we have added the abstractions that we absolutely need, and then anything else that cannot be abstracted is taken care by the tech team. And then reduce lock-in, right? So like I think you were saying, so if I pick a framework right now, let's say Crew AI, tomorrow if they release a new version, which is a more stable one, I would have to, number one, migrate my existing code to the new framework. That is one aspect. And then secondly, there will always be a learning curve when it comes to adopting a new framework, right? So we don't have to do that if we have built this in-house. Just to quickly summarize everything that I've covered, I think the core principles that we abide by are reliability. So we have checkpoints and state persistence in Redis, number one, which allows us to also resume from failure points, right? So basically, we have implemented durable execution by doing this. Determinism. So because of the strong guardrails that we have set for each agent and across the workflow, and because of our orchestrator actually taking control of the execution by decoupling intelligence from orchestration, I think that has allowed us to implement determinism. Scalability, again, queue-based execution, queue-based auto-scaling, number one, isolated queues per workflow allows us to be scalable. And then cost control because of all the guardrails, our alerts that we have set in place, so on and so forth. And just to, I think, just to summarize everything, I think this was a tweet that I read just last night. And I think the last paragraph really summarizes very well, all of the learnings that we have had so far. So I think the companies that will win with AI agents will not be the ones with the smartest model. They'll be the ones where engineers treat agents like junior employees with bad memory and worse judgment and build supervision around them accordingly. Right, so I think this approach of building a multi-agentic framework or a multi-agentic workflow has worked very well for us on production. Thank you, and happy to answer any questions. Yeah.
One thing that I've seen with my skills on agentic workflows is the determinism or the testing that I have to build around.
Yeah.
So the first time I test, but what if any one comes and changes any markup files or the flows? How do you test it? How do you ensure that the determinism?
So basically the evaluation strategy, or let's say evals of the system, right? Yeah. Yeah. So basically what we do is, there are two aspects to this. So one evaluation strategy is on the performance of the entire workflow or the orchestrator in itself, right? So we want to first ensure that the orchestrator is working as expected. By that what I mean is, given a use case and given an input, is the right sequence of agents being invoked? So that is one. Secondly, we also test for things like, how many times an API tool is or an agent tool is invoked. What is the latency of the entire workflow? All of that is, again, platform engineering apart from LLMs. So that is one aspect. The second part is when we actually want to determine how an agent is performing, or let's say how an LLM provider is performing, right? So in those cases, what we do is we track all of our cost. That is one aspect. Then we also benchmark different LLM models for a given use case, right? So for example, if I execute an AI agent against versus Gemini and Claude, I want to basically benchmark how the responses are for both of them, and then I choose the best one for my use case. So that is the second, like the third evaluation strategy. And then obviously we also have human QAs, or rather QA engineers, who actually have created test cases. And they actually create or execute those test cases against a certain test set, which also helps us to figure out if the workflow is performing as expected or not.
And the QA would be automated on a layer above the agent.
Correct. Yes. Yeah.
The human QA line is good.
Sorry.
Human QA.
Human QAs. Yeah. Yeah.
So could you talk a little bit about the scenarios that benefited from this? So if you go back to the first,
The problem statement.
yeah, like
Yeah.
so maybe I'll ask my question in relation to this, right? So if you look at this, you have so for example data ingestion or the ETL pipelines as you refer to. Each of those are basically so somewhere along your talk, I think it was not in reference to specific.
Yeah.
You saying that you saw that there were certain workflows that could be automated, hence you wrote this system.
Correct.
So can you give an example of that?
Yeah.
That's one, right? So that it just is
Mhm.
plays what scenarios. Second, what's the cost?
Hmm.
And by cost I mean the dollar cost is one number, but in all of this, what's the token cost? What's the context?
Mhm.
Did you run into limits with that?
Mhm.
How do you optimize that? So, for example, one thing that the skill files do, other than the garbage, is that they also reduce token usage.
Correct.
Because,
The context that I'm sending is restricted and determined. Yeah.
you are specifying like do exactly this instead of trying to figure
Correct.
out from the code base or whatever. So yeah, so those two questions, if you can speak about
Yeah.
particular scenario or set of scenarios. For example, data ingestion used to be because you say that, right? So each of these is complex.
Yeah. So I think the way that we benefited and we were able to solve this problem. So I think the major problem was the last line, right? So because of building all of this from scratch, our go time live was delayed, right? So that was the fundamental business problem that we were facing. By building this framework, what we were able to do is that we were able to,
But which step? So I'm sorry, I'm just trying
yeah,
to place this. So at which step? So which step was the most, what was the slowest? So was it data ingestion
data ingestion for the most part is usually the slowest.
or
Yeah. So writing ETL pipelines, I think, is still under our control. We have automated aspects of it. I think data ingestion, making sense of that data, figuring out how to store it in our data stores, that used to take a lot of time. So we have built agent skills or around that. That is one. Secondly, in order for me to go live with a new use case or for me to launch a new product, I don't have to collect, let's say, crores of records or data points before I can make sense of the data and abstract a product out of it. What I can do is I can build a multi-agentic framework. So basically, for me to power, let's say, my consumption plane, I'll have to have some data stored, readily available. I'll have to then build a search layer on top of it, and then build custom ETL pipelines, so on and so forth. Now, what I can instead do with this framework is that given a request, I can basically create a deep research, business-oriented workflow for me that can fetch all of the details that I need on demand. Right, so that is one aspect. So I don't have to, let's say, wait 8 or 9 months just to launch a product. I can simply create a workflow. I can fetch details on demand or data on demand, let's say, from each of these data sources, write ETL custom pipelines on the fly, and be done with it.
right? So that's it, right?
Yeah.
Custom pipelines on the fly. So your agent
Correct.
pipeline or standard
No, so what we do is we have an ETL framework in place already. We know how to write ETL pipelines. Code generation is always the easiest part, in my view, right? So given, let's say, the data that I'm dealing with and it's collecting on the fly, it automatically creates an ETL pipeline and gets done with it. It's an agent, yeah.
I think your knowledge repository is helping you to understand and build that
Correct. For example, just to give you one more example, let's say I want to fetch some data from a publicly available website, right, for compliance or whatever, right? Now, in such cases, we have defined the navigation flow of that website and, the limits that we don't want to reach as part of my knowledge repository, and then my agent leverages all of that along with, let's say, playwright MCP to get the details on the fly.
Manas, sorry, there are two questions from an online.
Yeah.
One is they want to see a demo, and the other
Okay.
is how do you ensure CLI commands are executed securely?
By giving the control of the execution to the orchestrator. So again, anytime I want to make, let's say, an important decision in my workflow, I delegate it to the orchestrator and not to an LLM agent. So again, so basically it's like the business logic or the sequence of the workflow or when to invoke what is controlled by the orchestrator, so that I don't allow and I don't basically give free will to an AI agent, so to speak. Yeah. Hmm. So I don't really have a statistic because there are just, again, I don't, so for example, I'm not sure if this will make sense, but then let's say for one of the use cases where we create, let's say, a 700-pager report, the entire workflow where there are multiple agents coordinating with each other, that takes about 10 to 12 minutes, and the cost is around $4.50 or so. No, again, not sure how you can relate with it, but then depends from workflow to workflow. But then we are tracking each cost, and then depending on the ticket size of the use case that we are getting from the client, we are able to take a call on which model to use for which agent in which use case. Yeah.
Yeah, someone else is asking, is your AI workflow using Airflow?
Airflow, we planned on using it. So I think for some of our periodic crons and for workflows that needed to be triggered periodically, we were using Airflow. But yeah, again, it can be replaced with any lightweight DAG service. Yeah.
So I have a question about skills, right?
Sorry.
Skills.
Skills. Okay.
Skills are dynamic or static? Static as of now.
Static. Yeah.
I have a question around the observability. You're talking about like you have done so many methods, like you talked about how you have improved the system. Just wanted to check how you do it, because that's one important thing.
Yeah.
Again, with the model performances, right, where like you have static skills, you might be changing it.
Yeah.
Seeing that is the performance improving.
Correct. So what we do is, so again, everything is instrumented, so that is one. So all of the logging events are basically published to, let's say, a landing zone, and then we have Logstash parsers or Beam pipelines where we ingest data in, let's say, ClickHouse. We build Metabase dashboards on top of it. We also use Grafana to monitor the performance and the usage. And combining all of this, we basically, get to know how the system is performing, and with our dashboards, we get to know how many failures are occurring on a daily basis. If there is an anomaly, the alerts are triggered, so on and so forth.
So you're saying now performances of the models, you are reaching to an empirical number by running the models on top of the logs which are emitting.
No, no. So basically, I did not understand the last part of the question.
One thing in the very beginning I told you, right, the model performances are not predictable.
Yeah,
Now you are making it predictable by the ecosystem what you have.
correct.
Reaching to that level, I'm sure that you have done a lot of iteration with these all tweaking.
Correct.
So to they you cannot measure it with true and false binary.
Correct. Yeah. So what? Understood. So basically what we do is, again, we take each AI agent individually, we look at it individually, we try different models for the execution of those agents. For example, for, let's say, report generation, I might not really need, let's say, Sonnet 4 or Opus, right? I can simply go ahead with using Gemini 3.1 and be done with it. These benchmarks are performed at a per agent level given the use case, and then we take a call on which model performs best for that use case, and then we glue it together. Yeah.
So one question actually, on the platform things I think we will summarize and then overall, different themes like scalability and reliability. I think security was missing there.
Mm-hmm.
Very specific reason. Just
No, agreed. Yeah. So I think, so everything, so what we basically, this agentic framework is also under a security governance of the other products that we have in IDfy. So the same, InfoSec policies apply there as well. So I did not talk about it because, yeah,
Because with LLMs, we are seeing prompt injections, right?
yeah,
Which were not possible earlier. Earlier, you would have this API, you're running your GPT and coming to know, what is the human vulnerability,
correct.
right? But here, you have the prompts available, right? People are, basically trying to, basically, write
Play around with or game the system, right? So the request validator takes care of all of that. So for example, if there are SQL injections happening, you flag that off. If there is anything else which is, so for example, all of the requests that comes to this agentic framework is via our consumption plane, which is the API or the UI portal, and we have validations on top of those APIs and the portals. So
So how does this validation happen? Like how does the sanity check happen? Like whatever prompts I'm giving, is it validating with pre-built
just to give you an example, let's say in a use case, we take address from the user and then we perform some property due diligence checks and then create a report out of it, right? Now, in such cases, the address is taken from a portal. There are particular validations on top of that portal. For example, you cannot enter a non-city in the city field, for example, right? If you are entering any text field, which is let's say a SQL injection, our backend service will perform validation on top of it. So the final response that you get, that the framework receives in the API will be sanitized, will be validated, and only then the agents will be invoked. So yes, so basically what we do is the CLI, what it does is it executes the markdown file, basically the agent, along with the parameters against which we want to send it. So for example, if I want to create a report using the report agent, what we do is we invoke the orchestrator will invoke the markdown file of that particular agent skill, that is one. It will also need the data points against which it needs to render the report, right? So that is passed as a parameter to the CLI command, and that template is written accordingly.
I was just hanging, so am I right in thinking that the CLI command template is also, because it says template, so then, does that also provide a layer of defense against things like?
So that layer of defense is again provided by orchestrator, but then again, once let's say Claude or any model, once it starts execution in runtime, then again, we don't really have control of. Correct. But the response that we send to the users, or what we want to do with the output, is again validated by orchestrator. But then in runtime, whatever the LLM model does is again something we don't really have control on.
One of the guardrail, one of the ultimate guardrail is obviously the principle of least privilege, right? So you do not give privileges, and you will not be.
Yeah.
But let's say if I have to give this platform to an SRE,
Mm-hmm.
to maintain the cluster, or let's say, there is one task, let's say, just for the sake of example, one of the tasks for SRE is to check the utilization of, let's say, different pods. And if there is a pod which is being continuously underutilized, the work for this SRE is to go ahead and either change the configuration or restart,
Mm-hmm.
bring down, vertically bring down. But if I give that kind of permission, then obviously it makes it
Mm-hmm.
powerful, right? You can go ahead. So in your case, in production, how are you dealing with providing what kind of control and providing?
So I think that is never so this was not the use case for us. I think our use case was very simple. We wanted to create a deep research output given some input, right? So in that case, the only permission that we wanted to give to our agents is the kind of tool sets that the agent can, work with, and that is part of the guardrails controller. So I think in your use case, for your use case, I might not even need, let's say, a multi-agentic framework or a workflow. I might maybe need, specialized agents that can do one task well.
Yeah, so the layer is behind that.
Correct.
The orchestrator is the one
Exactly. Yeah.
I have a question around the orchestrator. So, how do you codify the set of steps that the orchestrator has to orchestrate?
So basically what we do is our orchestration service, if I talk about the implementation, it's a two-step process. So one is we have created our own domain-specific language, DSL, which is JSON-based, where we specify each of the rules, the conditions of the execution, so on and so forth, error handling. And then we have the code executor step, which basically leverages a custom DSL file for each workflow and then runs the execution.
And how does it exactly talk to the agent?
Basically by CLI commands. So basically it leverages the markdown files from agent skills. Then based on the workflow that we have defined in the DSL, it invokes a particular CLI template along with the variables that the agent needs for its execution.
And the CLI, how does it again make calls?
So what it does is internally each markdown file has defined which tools to use and which, if we want to execute code, it is part of the markdown file. And then the execution happens in the containers runtime, Python runtime. So basically Claude has access to Python's runtime in the container. It will run the code if needed. It will invoke a agent tool if needed. All of that is controlled by the markdown file.
Okay, so you spawn containerized sandboxes for
Correct.
each agent run, and then you just close it off once the
Correct. Correct.
So, like you had mentioned reliability and then reliability, the exponential lack of circuit breaking and persistence.
Yeah.
So, do you all evaluate something like temporal to run such kind of thing?
For our orchestration service, yes. But then by then again, like in this case, we had already built an in-house lightweight system which uses our own custom DSL templates and our code executor. So we never felt the need to migrate to temporal. But temporal is a perfect use case for using for such kind of use cases.
On the LLM interaction part, other than the Redis memory caching, are there any other techniques or steps that you implemented?
Sorry, for which part?
On the LLM interaction part,
Yeah.
other than the Redis memory caching, have you like implemented any other techniques to like reduce token usage or to improve the model?
So the guardrails controller number one, that is one part. And then orchestrator decides the execution timeout for each agent. So by that.
Basically, the token usage, like there are like vector database for you can use embeddings and stuff.
Not really. For this use case, no. We were building that for, we started doing that in the original system. Then we ended up not using that.
Is there like some kind of quota that you set so that, like you mentioned, ballooning of LLM costs?
Mhm.
So, how do you prevent that?
There's no quota as such, but then we have alerts whenever there is a spike in, let's say, the output tokens, and then we take a call.
So, there's no rate limiting or anything that
Rate limiting in terms of, let's say, agent tools or the execution timeout, but no rate limiting on, let's say, the token usage.
I think people have more questions, so maybe we can take more this offline in our networking event after this. So,
Some tea and coffee as well. Still.
yeah.
Okay, but before that feedback form, next
Yeah.
meetup.
Yeah, so please provide your feedback. And this next meetup in June and July. June is in Bombay. I think this is being sponsored
In IDfy, yeah.
IDfy itself. And July will be in Bangalore. So once again, thank you all of you for your time. And special thanks to Riaz and Movie for hosting this meetup. And Janya for
Siddharth for
Siddharth for reviewing. Yeah. So
Cool.